Hello, Hunter and Brandon. Here we are at the inclined plane. We were developing it. You don't have to write this again, but we do find where you did write it. It was on your day 4 notes called inclined plane. Again, inclined planes are classic physics problems. Every physics student in the universe will study the inclined plane. So you get to join them today and continue our study. We started with what I call the theory model, and we're going to just simplify it to the working model that we'll actually use to do the problems. So can you find this? Where we drew the weight arrow down and we put in the perpendicular and the parallel components. You have that in front of you? Could you follow it at home, Emily? Pretty good?
Yeah, pretty good.
Okay. We haven't done any problems yet. So, all right. So have that in front of you because we're going to add to it. If you recall, yesterday that was right toward the end of class. So I got the most of it, but there's just a few more things I want to go back and add to the theory model, the one that we did all the work on. So observe that this component, which we called perpendicular to the inclined plane, is weight cosine theta, and the parallel one was weight sine. We could use that weight sine more effectively by moving it up here because it is the force that causes the box or object to go down the inclined plane. To counter it is the force of friction, which is going to always be mk if it's moving, and force normal, which we borrowed from here, weight cosine theta. So that's pretty much where we got to. What I want to add to this today is direction and angle. So we have to decide as a class whether we want going down the inclined plane to be positive. Some people like it to be positive because that's where we want the object to go. So we call going down positive. But some people feel, well, it's going down, so that's negative. So what do you want to call it? It's very arbitrary as long as we all do it the same. So it's not universally decided by some physics board somewhere.
Wait, so if it was like the triangle was going the other way, and it was, so say the slope was the other way,
it doesn't
would that
matter
be,
which way, right?
so it would still
if
be
we were
positive.
going this way, if we're going to call this negative, we'd call that negative. If we're going to call that positive. So what makes sense to your beautiful mind? You don't care?
Down negative makes more sense to me.
Down is
Yeah.
negative?
Yeah.
Okay.
Yeah, down negative.
All right, we'll go with that. So we'll say going down the plane is negative and going up is positive. So we'll call force of friction a positive force and the force that pushes it down the negative force. If the triangle is this way, we will do it with similar meaning, down negative, back up positive. That's fine. It doesn't really matter. I think that's actually how, if I had a choice, I did it, but I have seen it the other way. All right. Now I promised to add in our signs, but also angle. It doesn't help very much to know that angle because when you are sitting an object on the inclined plane, are you going to know that angle? Are you going to be able to see a vector shooting out of the object down to the center of the earth and draw in the parallel and perpendicular components and create that angle and measure it? It's not going to be practical to use that angle. We needed that angle to do some trig to get these parts, but now let's find an angle that is practical to use in this problem. So I am going to ask you to come back to me from geometry class. So I am going to create 2 parallel lines. Do you see that these are parallel? I think you can see that. These are parallel lines. We're going to indicate that with the little arrowheads somewhere in the middle of the parallel lines. And we're going to cut the parallel lines by what? What do we cut parallel lines with? Transversals. So here's this right here looks like a fine transversal. I'll just extend it. So I took lines that were already on our theory model And I notice these two are parallel, and anything that cuts parallel lines is a transversal. When that happens, alternate interior angles are equal. So this angle is an alternate interior angle to what angle?
You know, these are all really big words. It's just that one and that one.
All right, that one and that one.
You
All
can
right.
call them similar angles.
So
You have to call them
I do it
similar
like
alternate interior angles.
this angle, not this square angle, but this where that orange meets the pink. This is an alternate interior angle to that. This and that are equal. Let's take, is this angle going to help us? Are we going to be able to find that angle in a lab situation? All right, so now we're going to use this angle to find a better one. So this angle is part of this triangle that I'm striping. And it has a right angle here, and this angle, I'll call this angle A. Can you find another triangle that is similar? May I use that word? Similar. Can I find a triangle that's similar to this triangle that I striped? The one with the orange side, the pink side, and part of the side from the inclined plane. Well,
Yep.
which one?
Let's see here. So, if you made a perpendicular segment, and then which would be so the inclined line of the triangle,
Right?
and it has perpendicular line coming out the bottom,
This
which
one?
is the transversal.
Yeah. So this
so
one?
that means that
This one?
that means angle theta should be the same from the original angle of theta to the one on the right,
All right.
right
So
above the
this
90
one is
because-
similar. You're right, because it has this angle in common and a right angle in common. If you find two
This should
angles,
be theta as well.
Ryan,
now that one's not theta.
Ryan, listen, I'm the captain now.
It's not. That one's not theta. It doesn't cut that in half necessarily. So, but there
These
you
are-
find
these are
another
square
triangle.
Heebie-jeebies.
So where's another one you're saying?
One day, I
it
told
should be
everyone
right
at
here
lunch, no one was
because we have
listening.
perpendicular-
Except for MQ.
That's all that was, okay.
Yeah, but this is not in half.
Yeah, you get a pass.
Because this side is
get a
longer
pass.
than this side.
Alright.
So it's
Yeah,
not
I
in
mean,
half.
I kind of
But
wasn't sure if I was
as
going to
long
come to school.
as long as
I
these
was like,
points
I'll go tomorrow. And yesterday, I was like, I do not.
as long as these lines are set at
Did they like make you pass
one
out?
point
No,
on
it
the
doesn't hurt
triangle
that
and that
much. I
and
just
those two
did it
points
once.
make a right angle.
You need to sleep?
No, I mean, it kind of hurt. But it was more like I didn't know really
Even-
where much to
even if
wear.
that line's on let's call it in the freezing cold.
I understand
It's
what
not
you
He
mean.
gets me. I didn't want to like have to wear like.
So you're still thinking this and
And
that
it's
are
freezing
equal.
this
Well,
floor.
this
And I was
makes
like,
this
I have to do that.
close.
And there's
right
like blood
angle,
on it. I was like, I don't feel like dealing with this.
I mean,
Now
this
it's
right
right
angle is
there
cut in half by this
Check
line.
this.
Right, you're on the right track, but it's not this angle that's equal to that.
Oh.
What angle is equal
And then
to
they
that?
put this stuff in it. It's supposed to kill the root.
Don't
So
tell
it
me
doesn't come
Oh,
back.
no,
Because
that's
they're
just using-
similar. They're
This is
just,
using 90.
We'll do surgery today.
alright, watch. Alright, so
It's all
the one
colored
that's
in there.
striped yellow is similar to the one that's striped green. But neither one of those is very helpful to us because this angle theta and this angle theta are not. There is another triangle that is similar to both of these. It has this angle A and it has this right angle, and it is the actual incline itself. So another color, I don't have another color, do I? I got purple, is purple up there? This triangle, right here, the actual incline, look at it. Does the purple triangle have angle A?
Yes.
Yes.
Does it have a right angle
Yes.
Yes.
over here?
Yes.
So therefore, it is similar to this triangle. So this angle theta is right there. Is that a practical one for us to use?
Definitely.
Yeah, we can use that one. So, again, this is our theory model, and we need to come over here and sort of simplify it. We're not going to draw that every time we do a problem. So what do we need when we do a problem? I'm going to simplify it and call it our working model, which I started yesterday. So our working model will be the inclined plane. You can draw it the other way, make sure it's a right angle. This is theta, that's all you need. And this is weight sine theta. And this is mk, weight cosine theta. And we do have to know the mass of it, so whatever, so many kilograms. So we do have to know the mass or the weight of the object. With that, that's all we need to do our problems. So I had to go to the theory model to give you these parts. So now that you have them, this is all we need. And if you memorize that, or can remember where those came from, you're good. All right, I'll do one problem and you'll do 4, and then we'll break and do it in a similar thing in lab. So that's our plan for today. Shortened class, so I'm not sure we'll get that far, but we'll give it a whirl. Let's say problem number 1, draw it out on your sheet there. Problem number 1, and we're going to have an inclined plane. It is known to be a right angle here, 30 degrees here, and the weight of the box is 30 newtons. Let's say the 0 is significant, so we'll have 2 sig figs there. The coefficient of kinetic friction was, or is, 0.12. Find the acceleration down the block. So once you have those parts written, let's go ahead and do this problem. You'll find these are rather quick compared to torque problems. These are rather quick. And compared to the hanging picture tension problems. So these will probably be your favorite ones in the mod. So sum of the forces equals MA. If you don't know where to start, at least give me that. You'll get a point or 2 for that. All right.
All right, bye.
All right.